So today let us start the discussion on unit 2 of your embedded system, that is architecture of embedded systems. Okay. So as you have seen in the first unit, that is embedded system, it is a combination of both hardware and software. So let us study which are the different blocks that are present in an embedded system. Okay, as you can see here, an embedded system mainly consists of a system core. This is the main brain of the embedded system. Okay, so this is a controller which is going to control your whole of the embedded system. So we need a system core or a controller. Okay, so this is your main brain of your embedded system. Okay, then when there is a processor, obviously we need what? The program to control it. So that program will be stored in this memory. Okay, so we need a memory to store the program. That program is going to execute. That program will be executed by this processor, and the whole embedded system will be controlled by this processor. Okay, so we have a processor here and we have a memory here. Okay, so the firmware or the software will be placed, it will be stored inside this memory. Okay, then what else we have here? We have input ports. Okay, so when I say embedded system, okay, obviously it is going to interact with the external world. Okay, so it needs to receive inputs from the external world. So it will have input ports, and number of sensors or input devices will be connected to the embedded system here. So we have input ports to which sensors will be connected. So for example, our phone is one of the embedded system. So how we are going to interact with the phone? I have a touch screen. Through that I am going to dial the number. So in this way that dial number will be given to the internal circuit. Okay, so the touch screen is acting as the input sensor for your mobile phone. Similarly, we have a air conditioner. Okay, so through my remote I am going to set the temperature. So the remote is one of the input devices for your AC, air conditioner. So in this way, every embedded system, it needs to sense the variables or signals from the external world. So it will have input ports. So the sensors or the input devices will be connected to the input system here, input ports here. Okay, then on the other side we have output ports. Okay, so when the embedded system receives the input from the input devices, okay, it processes those input signals with the help of this program, and it is going to generate the new output. That output is going to control one of the parameters of the external world, or some other device, external device will be controlled by the embedded system. So that device, those parameters which are to be controlled by the embedded system are connected to the output ports. So those are actually called as actuators. So for example, it may be an LED, or it may be a speaker, or it may be a LED 7-segment display, or it may be a motor that has to be turned on or off based on the output signal here. All those things we are going to connect here. So those are called as actuators. Okay, so what we have in embedded system, we have a processor here to control the embedded system. The processor needs the program, okay, to execute. That program will be stored in the memory. So we have processor, memory, and we have input devices, so that the embedded system can sense the external world variables or signals. Then after processing those signals, it is going to generate new outputs which are going to control some other devices which are connected to the output ports. So these devices are called as what? Actuators. Okay, so these are the 4 main parts that will be available in an embedded system. Also very important thing, see here we have a communication interface. Okay, it may be USB or it may be I2C. So like this embedded system may want to communicate with some other device or some other embedded system. So for that purpose, this embedded system should have the capability to communicate or to talk with some other devices. So for that we have a communication interface as well. Okay, so this embedded system, this whole embedded system can communicate with other devices. So what are the examples for communication interface? It may be USB, I2C, okay, parallel port. Okay, so like this we have different types of communication facilities. Maybe your Bluetooth, okay, Wi-Fi. So any one kind of communication or more than one kind of communication systems will be present in the embedded system, which enable this embedded system to talk with the other external devices. Okay, then if the embedded system needs some other supporting hardware circuits and other systems, they will be connected to the embedded system as well. Okay, so this is the diagram that is showing which are the different parts of the blocks that are present in an embedded system. Okay, so now we have to study one by one in detail what are the whatever I mean by system core, which are the processors we can use here, which are the different types of memories that can be used here, which are the different types of sensors that can be connected, which are the different types of actuators, all these things. Okay, we have to study in detail. So today let us study only this part, that is the system core, okay, which is the main part of the embedded system. Okay, so the core of the embedded system, that is the system core, okay, it is going to control the whole embedded system. Okay, so which processors can be used as the core of this embedded system here? See here, there are four options available. One is either you can use any general purpose, okay, processor, or a domain specific processor. Okay, this any one of these you can use it as the system core here. Okay, which are the processors available in this category? Either you can use microprocessors or microcontrollers, or we can use DSP processors, digital signal processors, or you can go for application specific integrated circuit. In short form, it is called as ASIC. Okay, this you can use it as your processor in the embedded system, or you can use programmable logic devices for controlling your embedded system, or you can use some other systems are available, they are called as COTs, commercially off the shelf components. So any one of them you can use it as the processor in your embedded system. So let us see them one by one again. Okay, so actually mainly there are four categories: general purpose processors, ASIC processors, PLDs, and commercially off the shelf components. Okay, so let us see the first one. Okay, so general purpose or and domain specific processors can be used for controlling your embedded system. Okay, so in industry which are using embedded systems, many of them, most of the industrial embedded systems will have either microprocessors or they will have microcontrollers. Okay, so in industry we have number of embedded systems which are going to control the different operations in the industry. So those embedded systems will usually be having microprocessors or microcontrollers for controlling the embedded system. Now if there is any embedded system, okay, which needs special type of signal processing, such as I want to process the speech, then such embedded systems will need some special kind of processors. Those are called as digital signal processors. Okay, so these three kind of processors, they come under this category: general purpose and domain specific processors. So let us see what is a microprocessor. Already you have seen what is a microprocessor. So microprocessor, this can be used as the main system core of your embedded system. Okay, so what this microprocessor will contain, it will have an arithmetic and logical unit, okay, and a control unit. Okay, so this microprocessor, okay, it will have ALU plus control unit, CU. But since this microprocessor only has these two units, directly only this microprocessor IC, okay, I cannot use it to control the embedded system. I need to add some extra circuits to this microprocessor IC. Okay, so which are the extra circuits that are needed for this microprocessor so that it can become a fully functional processor? I need to add memory to this microprocessor to store the program and data. I need to add the timers. Okay, then you have to add interrupt controllers, then you have to add some additional ports if required. So these things if you add to this microprocessor, then it can function as a controller, okay, processor. Only if you have only this microprocessor IC, then if you directly want to use it in any system, it is not possible, because this processor has only ALU and control unit. These two, only these two cannot perform anything. Okay, it will not work. So to this microprocessor IC, we have to add all these things: memory, timers, interrupt controllers. Then only it will become a functional unit and it can start controlling any of the embedded system. Okay, so the microprocessor can be used along with these circuits to control the embedded system. So which are the examples for microprocessor? So the Intel company has designed, initially it has designed one of the oldest processor, that is called as Intel 8080. Okay, also there is one more processor 8085. These were the earliest embedded processors that were designed by Intel company. Then there is one more company called Zilog. So it also designed one processor called Z80. This was a competitor to this 8085 microprocessor. Okay, and there is AMD company that also manufactures microprocessors. You can use any one of them for controlling your embedded system. Okay, so the first one is you can use microprocessor. Okay, then we can use what? Instead of microprocessor, we can use a microcontroller to control the embedded system. Okay, so what this microcontroller will have? This microcontroller has ALU, just like your microprocessor, and control unit. In your microprocessor, only these two are there, but whereas in your microcontroller, it has an ALU, okay, control unit, plus those things that you used to add extra. Okay, it will have everything. It will have memory for storing the program and the code. Okay, then it will have the timers built into the microcontroller. It will have interrupt controllers. Okay, then it will have ports. So all these things are present inside the microcontroller IC. Okay, so there is no need to add any extra circuits to make this microcontroller functional. So this microcontroller IC you can directly procure it from the market, then you can place it into the microcontroller embedded system. You can start using it by writing the program to the microcontroller. Okay, so there is no need to add any extra circuit. Just as you add to the microprocessor, there is no need to add any circuits extra to this microcontroller. Okay, directly you can get the microcontroller IC, you can put it in your embedded system and it will start functioning. Okay, now which are the example of microcontroller? Already we have studied one of the microcontrollers in your 4th semester, that is Intel 8051. Okay, this is one of the very good microcontroller. You can use it for controlling your embedded systems. Okay, other one is there is something called PIC microcontrollers. So the Microchip Technologies company manufactures one more kind of microcontrollers. They are called as PIC microcontrollers. So you can use this PIC microcontrollers also for controlling your embedded systems. Okay, then I can use the digital signal processor, DSP processor, to control the embedded system. So what is the need of using this digital signal processor? Okay, sometimes I need to process audio and video, and for some communication applications I want a processor. Okay, in such applications, okay, if I use either microcontroller or microprocessor, the processing becomes very slow. So at that point of time, what I want a processor that can process at a faster rate compared to the microprocessor and microcontrollers. So at that, in such kind of applications, we can use digital signal processors. We can process audio, video and other communication circuits, communication signals at a much 2 to 3 times faster compared to your microprocessors and microcontrollers. Okay, so why these DSPs are faster compared to your general purpose processors? Because in DSP the logic or the algorithm is implemented in hardware, whereas in your general purpose processors the algorithm is implemented in software. So that is, since the algorithm is implemented in hardware, in case of DSP processors, the speed of execution of the program will be, processing will be much faster in case of DSP processors. Okay, what this DSP processor will have? It will have a program memory for storing the program. It will have a data memory for storing the data. Then it will have computational engine, okay, that is main execution part. Then it will have input output units. So these 4 things will be present in the digital signal processor. Okay, we can use this DSP in applications where the embedded system is going to process the audio signals or video signals, or in some of the communication applications. Okay, these things we can use. So these 3 things, microprocessors, microcontrollers and digital signal processors, they fall under the first category, that is general purpose and application specific processors. Okay, then which is the second kind of processors we can use in embedded system? They are called as ASIC, application specific integrated circuit. Okay, so this application specific integrated circuit means what? These are integrated circuits. Okay, these are the ICs that are designed for a specific application. Okay, so these ICs are designed for specific application. Okay, so these ASIC ICs will act as a replacement to the conventional general purpose processors. So already we have seen we can use a microprocessor or microcontroller. Okay, but suppose I have an already built-in custom IC that has been designed for a specific embedded system, I can use that IC for my embedded system instead of using microcontrollers or microprocessors. So this ASIC IC will implement many of the functionalities into a single chip. Okay, therefore the development cost will be reduced to a greater extent if you use this application specific integrated circuits. So what is the meaning of this application specific integrated circuit? This is an IC just like your microcontroller or microprocessor, but it will be designed for a specific application. For example, in a refrigerator, I want to use a processor. There will be some ICs available which can control the refrigerator. You can directly use them. No need to put a microcontroller and write the program for controlling the refrigerator. We have to modify that. Okay, so you have to make sure that the processor will be well designed for well coordinating with the your refrigerator. So instead of that, already in the market, application specific ICs will be available which are well suited for controlling your particular embedded system that you can use for controlling your embedded system. This is second type of processor, we can use it in embedded system, that is ASIC. And the third type of embedded controller that we can use is, it is called as PLDs, programmable logic devices. Okay, so what do you mean by logic device? Logic device means what? Already you have used these logic devices in the lab, that is fixed logic devices we have used. For example, we have used IC, okay, 7432 OR IC. So what it performs, it does the logical OR operation. Okay, so such kind of IC 7432, 7408, these devices, okay, their functionality remains the same. If I take any OR IC and IC, okay, always it will do the AND operation only. It is not going to change its operation. The AND IC will not act as a OR IC. Okay, the OR IC will not act as a NOT IC because their operation remains fixed. Such kind of devices, they are called as fixed logic devices. Okay, now there is a more kind of logic devices, they are called as programmable logic devices. Okay, so what this word programmable indicates, in such kind of logic devices, okay, the logic can be changed. This logic can be changed by using the programs. Okay, so if I write the logic program for implementing AND operation, and if I put that program into this IC, then it becomes, this IC becomes AND IC. Now the next time I will write the program for OR operation, I will place that program into this IC, then this IC becomes the OR IC, AND IC, and AND IC. Like this, the working of this IC or this logic device, it depends on what type of program you have put into this IC. Okay, but whereas in case of fixed logic devices, okay, the logic will be fixed. The working of this IC will not change. For example, 7432, 7404. So those ICs, they are called as fixed logic devices. Okay, we have one more kind of devices that is called as programmable logic devices, where you can design your own custom logic, digital logic. You can place that logic into these logic devices. Okay, so this kind of programmable logic devices can also be used for controlling your embedded system. So which are the examples for this PLDs? One is called as FPGA, Field Programmable Gate Array, and there is one more type of PLD that is called as CPLD, Complex Programmable Logic Device. Either you can use FPGA or CPLD IC for controlling your embedded system. So for using these two, CPLD or FPGA, what you have to do, suppose you want to use them as a processor in your embedded system. So what you have to do, you have to write the program as to how your processor is going to work. You have to write the program for that processor. You have to put that program in this IC, CPLD or this FPGA. Then this FPGA or CPLD, it will start working as the processor. Then you can use it for controlling your embedded system. Now what is the advantage of using this FPGA or CPLD? Okay, it is very flexible during the design process. Suppose I want to my IC, my processor to perform like this. I have some idea in my mind, so I will write the program for that particular processor. Okay, I will put that in either CPLD or FPGA. Then I will check whether the processor is working according to my needs or not. If there is some error, then I will modify the program. Again, I will put that into my processor. Once again, I will write back the program by doing the modifications in the program. So during development phase, design phase, it is very easy. Okay, it is very advantages to use this FPGA or CPLD in your embedded system, because you don't know how your system processor is going to work. Okay, during that time design phase, suppose your logic changes, okay, then what we have to do? So you want to change your logic, just you have to change the program, okay, and that new program you have to put into this IC, then the working of this IC will change. Okay, so instead of this, if you use fixed logic devices, then if you want to change the logic, then you have to change the whole circuit. Okay, you have to procure new logic devices from the market, you have to connect them, you have to check them. So instead of that, if you go for FPGA or CPLD, then the designing of any embedded system becomes, it is very easy. Then the next advantage is they are very easily available in the market. Okay, you can directly procure them from the market, write the program, put that program into the IC, then it will start working as your process controller in your embedded system. Then the one more advantage of this programmable devices is they are reprogrammable even after procuring. Suppose you have already purchased one device from the market, okay, and at that time, if the manufacturer has already written the program for you in the IC, then after purchasing the IC also, you yourself user can change the program and he can use it. Okay, so these are the main advantages of using this programmable logic devices in the embedded system for controlling your embedded systems. Okay, so which is the next type of processors we can use in our embedded system? They are called as COTs, commercially off the shelf components. Okay, so these commercially off the shelf means what? Suppose I want a RF circuit or radio frequency controller circuit in my toy car. RF remote control toy car, we have a controller circuit. I am building a new remote controlled car, okay, for children. Then I want to have a controller circuit. Okay, so if you start building from the scratch by taking a general purpose computer, it takes a lot of time. So instead of that, what I can do? Already in the market there are RF circuits available, control circuits available, which are designed for this RF functionality. You can directly purchase it from the market and you can put it in your circuit. Okay. Similarly, if you want to have IR detectors or ultraviolet detectors, okay, such kind of circuits are also processors are available in the market. So these kind of circuits which are readily available in the market, they are called as COTs, commercially off the shelf components. You can directly procure them from the market, you can start using them in your circuit. Okay, so these COTs are designed by using this general purpose circuits or processors only. Okay, so they are readily available in the market. You can directly go to the market, purchase the required circuit, okay, and you can put that in your embedded system for controlling your embedded system or any other part, not only the processor, any other part of your embedded system. If it is available directly in the market, you can, that is called as COTs, you can procure it from the market. Okay, then you can start using it in your embedded system. Okay, so this is the one more type of processor. If it is readily available in the market, procure it from the market, directly put it in your embedded system, that is called as COTs. Okay, so these are the different types of processors we can use in your embedded system. Okay,